Assalamu alaikum guys, welcome. Okay, so now we are going to talk about a very important section of period 3, that is the trend of melting points of all these elements. Okay, this is a very high yield topic, literally a very high yield topic, because you will find only from this diagram you can find like 5 questions, okay, just on this board. Alright, so this is that important, and not 1 mark questions, rather 3 to 4 mark questions. Okay, so this is going to be a very important discussion, so let's begin. All right, so now sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine and argon. Now what do you guys think, which of these will have the highest melting point and why? That's the question basically. Explain, describe and explain the trend of melting points basically, that's actually the question. So first of all, sodium, magnesium, aluminum. Sodium, magnesium, aluminum. As you go from sodium to aluminum, this is the first part of the question. Silicon itself is a question. Phosphorus till argon is a separate question. So 3 questions, and the 4th question is this graph, this diagram basically. You are asked to actually draw the diagram. Okay, so this is important. Sodium has a particular melting point. Magnesium will have a higher melting point. I'll explain why. Okay, then aluminum will have a slightly higher melting point than magnesium. And then silicon will have the highest melting point. I'll explain why. Then phosphorus, after silicon, phosphorus has a lower melting point as compared to sodium and magnesium. Then comes sulfur, then chlorine, then argon, and sulfur has a higher melting point than phosphorus. Why? That's also a question. This is the 4th question you have. Why is sulfur above phosphorus? And then comes chlorine, and then comes argon. So now let's explain why is that so. First part is this one. Sodium, magnesium, aluminum. Sodium followed by magnesium and then followed by aluminum. Why is aluminum having the highest melting point and why is sodium having the least melting point? First of all guys, what is the type of bonding on which the melting point depends in these 3 metals? It's the metallic bonding, right? So this is the first thing, metallic bonding. Now this is the first key term and this is the first mark for, okay? First mark is actually given for the metallic bonding. Second term is that as you go from sodium to magnesium to aluminum, the valence shell electrons increase, right? Valence shell electrons, they increase from 1 to 3, right? Sodium has only 1 valence shell electron, aluminum has 3 valence shell electrons. Now the valence shell electrons, they are donated to the sea of delocalized electrons. Donated to the sea of delocalized electrons. Sea of delocalized electrons. Since aluminum donates the greatest number of electrons, since aluminum, it donates the greatest number of electrons to the sea of delocalized electron, therefore aluminum has the strongest metallic bonds, right? Metallic bonds. And so greatest energy is needed to overcome the metallic bonds present in aluminum. That's the reason. So what are the marks for over here? First of all, you have to mention that the melting points of all these 3 elements depends upon the metallic bonding present inside of them. As we go from sodium to aluminum, the number of valence shell electrons increase. The valence shell electrons are provided to the sea of delocalized electrons in the metallic bonds. So the greatest number of valence shell electrons are provided by aluminum, therefore the strongest attraction exists in aluminum, and so the greatest energy is needed to overcome the melting point, the metallic bonds present in aluminum. That's the answer, that's complete, and that's the reason behind it. Clear? Then after aluminum comes silicon. Sometimes the examiner asks you that why is silicon having the highest melting point? Why is that so? Meaning not above just aluminum, but rather the highest, even above the non-metals and the metals and everything else. Why is that so? The reason behind that is because you guys might already know this answer, by the way. Silicon, remember a compound of silicon which we did previously in covalent bonding, silicon dioxide, SiO2. Remember SiO2? SiO2 has giant covalent structure. Same is the case with silicon. Silicon also has a giant covalent structure. Giant covalent structure means it has thousands and thousands of bonds, covalent bonds of silicon bonded with one another. Basically, I'll draw the structure of silicon. In silicon, basically, each silicon atom is bonded to 4 other silicon atoms, which in turn are bonded to 4 more silicon atoms, and so you get a tetrahedral structure of, and the bond angle is of course going to be 109.5 degrees. The shape is going to be tetrahedral. hydral, and it has a giant covalent structure. And so if it has a giant covalent structure, then that means a lot of covalent bonds need to be broken down before it could be molten, right? Before it could melt. So therefore it will require the greatest amount of heat energy or greatest amount of energy to break the covalent bonds, all the covalent bonds present in silicon, in order to melt it down. So that's the major reason. That's the answer to that question. Why the silicon has the highest melting point? Because silicon has the giant covalent structure, and there are many covalent bonds. The highest amount of energy is needed to overcome them as compared to other elements which are present over here. Then phosphorus, sulfur, chlorine and argon. These four elements have a separate question. Actually, they have two separate questions. Okay, so now phosphorus, sulfur, chlorine and argon. Now sulfur has the highest melting point, followed by phosphorus, followed by chlorine, and then finally argon. This is the reason why the melting point of sulfur is the highest, because sulfur naturally exists in the form of S8 molecule, okay, as an octamer. Okay, sulfur has 8 sulfur atoms bonded to one another. 1, 2, 3, 4, 5, 6, 7, 8. Okay, it actually has 8 sulfur atoms bonded to one another, due to which what happens, sorry about that, due to which each the amount of covalent bonds which are present in sulfur are more as compared to, actually sorry guys, big mistake. It's not the covalent bonds in case of sulfur, phosphorus, chlorine and argon. It's not the covalent bonds on which the melting point depends. Any suggestion which forces are responsible for the melting point in these elements, chlorine and argon? Let me just hint you over here. These are non-polar compounds. And if these are non-polar compounds, that means it's the van der Waals forces which are responsible for the melting points in these elements. Okay, first mark is for this statement over here. First mark is to explain that sulfur has 8 atoms in each molecule, phosphorus has 4, chlorine has 2 and argon has a single molecule. Second mark is S8 has the highest MR. Remember, van der Waals forces depend upon the MR, right? And if it has the highest MR, then it must have the highest number of polarizable electrons. Remember polarizable electrons from the previous lecture of van der Waals forces, intermolecular forces? Okay, S8 has the highest number of polarizable electrons, therefore S8 has the strongest van der Waals forces, strongest VDW forces. And if it has the strongest van der Waals forces, then of course the greatest amount of energy will be needed to overcome them in case of sulfur, and therefore it will have the greatest melting point. And there is also, most of the times there is an additional mark for stating that the melting point of these elements, melting point, it actually depends upon the van der Waals forces. Okay, for just this statement there is sometimes a mark is actually available. Okay, so it's better to write down everything. So the first mark is for this comparison, that S8 is greater than phosphorus, is greater than Cl2 and is greater than argon. Then mentioning that sulfur has the greatest MR, okay, and the greatest number of polarizable electrons, therefore it will have the strongest van der Waals forces, and so the greatest amount of energy will be needed to overcome the sulfur, intermolecular forces in case of sulfur. And this completes our discussion on melting point strength. Okay, quick recap: sodium, magnesium, aluminum. Aluminum has the highest. And by the way, there is just one last question which is left over here, from sodium to magnesium and magnesium to aluminum. This difference in the melting points, I'll explain that in the next video. Okay, but before that, everything else has been completed. I'll just do a quick recap of what we've done so far, and then we'll move on to the next lecture. So from sodium to magnesium to aluminum, the melting point increases because of the increase in the strength of the metallic bonds. And then from aluminum to silicon, silicon has the highest because it has a giant covalent structure, and most energy is needed to overcome that. Then from phosphorus Phosphorus has lower energy than silicon because it has van der Waals forces, and silicon has covalent bonds which are stronger. Then sulfur has higher energy than, higher melting point than phosphorus, because sulfur actually has a greater MR. It exists as S8, and S8 has the greatest MR and the greatest number of polarizable electrons. So greatest amount of energy would be needed to overcome them. So strongest van der Waals forces basically. Then coming to chlorine, which has a lower MR, and then argon the least MR, so least van der Waals forces, meaning the weakest van der Waals forces. This completes it. We are gonna discuss this difference in the next lecture, and then we are gonna move on. Thank you.